All right, let's jump right in. Today we're tackling a big one, the main circuit for a reversible star delta starter. My goal here is to break this thing down step by step so you can draw it from memory with total confidence every single time. And hey, let's be honest, it really can feel that way. I mean, if you've ever just stared at a blank piece of paper wondering where on earth to start with this circuit, trust me, you are definitely not alone. It's because it's doing a couple of things at once, and that's really where the confusion starts. But here's the secret to cracking it, and it's actually pretty simple. This isn't one giant, impossibly complex circuit. It's really just two simpler ideas, direction control and a starting method, that have been combined into a single diagram. As soon as you see it that way, I promise, the whole thing just clicks. So here's our game plan. We'll start by making sure we understand those two logics. Then we'll get our components ready, kind of like our toolbox. After that, we'll build the circuit in two really clear stages. And once it's built, we'll walk through how it works and finish up with the critical rules you just can't forget. Okay, let's dive in. The whole point of this starter is to do two main jobs. Job number one, it has to control which way the motor spins, forward or reverse. And job number two, it has to start that motor gently. It uses the star delta method to reduce that initial jolt of voltage and current when it first kicks on. Now, before we even think about drawing a single line, let's get our tools in order, right? Just like any job, knowing your components and what their symbols look like is always step one to getting a clean, correct diagram. And what's at the heart of this entire setup? It's these four contactors. That's it. Two are going to handle the direction, and the other two will handle the star delta start. Keep that number 4 in your head as we build this thing out. And here they are, our main players. We've got our three-phase supply, of course, our circuit breaker, Q1, the four contactors, K1 for forward, K2 for reverse, K3 for delta, and K4 for star. Then our thermal overload, F1, and finally our 6-terminal motor. That's the whole team. All right, let's get to it. Time to start building the circuit. We're going to start with the first logic, which is just controlling the direction. This is the part of the circuit that decides if the motor runs forwards or backwards, and it only involves two contactors, K1 and K2. And this part's actually really straightforward. First, you're just going to draw your 3 supply lines running down the page with the breaker, Q1, right at the top. Below that, draw your forward contactor, K1, and just connect the phases straight through. Then, right next to it, in parallel, you'll draw K2, the reverse contactor. Now this right here, this is the whole magic trick for reversing a 3-phase motor. Look at K2. To make it run in reverse, you just swap any two of the phases as they pass through the contactor. In this case, you see line 1 goes to line 3's output, and line 3 goes to line 1's. That simple swap is what flips the motor's magnetic field and makes it spin the other way. Perfect. We've got our direction control locked down. Now we just need to add the second part of our circuit, the star delta components. This is what gives us that smooth, soft start. This part involves the motor terminals, the thermal overload, and our other two contactors, K3 and K4. So let's wire this second half up. We'll start by placing the thermal overload, F1, right underneath our K1 and K2 contactors. The power flows from there down to the motor's first set of terminals. That's U1, V1, and W1. Now, from the motor's other set of terminals, U2, V2, and W2, we're going to create a split path that goes up to both our star contactor, K4, and our delta contactor, K3. Now, the job of K4, the star contactor, it's so simple, but it's absolutely vital. All it does is take the 3 phases coming from U2, V2, and W2 and shorts them together on its output side. That's it. It creates what we call a star point. That is its entire job. Okay, so the circuit is drawn. The whole thing is laid out. Now for the fun part. Let's walk through the actual sequence of events. What really happens second by second when you press that start button. Okay, so picture this. You hit the start button. Instantly, 2 things happen. The K4 star contactor and the K1 forward contactor pull in together. The motor starts up, but nice and gentle. After a few seconds, a timer in the control circuit tells K4 to open up. Then, a split second later, K3, the delta contactor, slams shut. And now, the motor is in its full power running state, with just K1 and K3 engaged. So, we've drawn the circuit, and we know how it works. But look, drawing it is one thing. Making sure it's safe and that it actually functions correctly, that's another story. And for that, there are a few golden rules you absolutely have to remember. Okay, rule number 1, And listen up because this is absolutely non-negotiable. You must have mechanical interlocks. You need one between K1 and K2 to physically stop them from closing at the same time. Because if they did, you'd have a massive short circuit across your supply. And you need another one between K3 and K4 for the same reason. This is probably the single most important safety feature in the entire circuit. Now, I want you to burn this number into your brain, 0.58. Seriously, this isn't just some random number. It is one of the most critical figures when it comes to properly protecting the motor in this specific setup. So here's why. In a delta configuration, the current that's actually running through the motor's windings is different from the current that's coming down the line to the motor. And if you look at our diagram, our thermal overload, F1, is positioned where it only measures that smaller winding current. That's why we can't just set the overload to the motor's nameplate current. To set it right, you have to take that full line current from the nameplate and multiply it by 0.58. That scales it down perfectly, making sure the motor is protected without tripping all the time. And just like that, you've done it. You've taken this seemingly complicated circuit, you've broken it down into logical pieces, you've built it, and now you understand the key rules for making it safe and reliable. The main circuit is no longer a mystery. So the only question left is, are you ready to tackle the control circuit that makes all this magic happen?